Hello all. In this video we would learn about the fourth commutation relations on angular momentum. It's also based on the ladder operator which we had earlier seen. That is, we call it J plus and J minus. Just a recap of the previous videos. First we started with the basic commutation relation, and we told that every commutation relation follows from this basic commutation relation. It is nothing but commutation Ji Jj is equal to I epsilon ijk jk, and you know epsilon ijk is a Levi-Stator tensor, and this is equal to 1 when I, j, k are even indices. It is equal to -1 when they are odd indices, and is equal to 0 when any of the two indices are the same. So that was our first equation in the first video on commutation relations on angular momentum. In the next one, we talked about J square, and we defined it as Jx plus Jy plus Jz. Again, based on this, we saw that J square commutes with all jk's, which means that J square Jx is equal to, commutation is equal to J square Jx is equal to J square Jy is equal to J square Jz is equal to 0. So that was our second lecture. In the third one, we derived, or we just talked about the simultaneous eigenket, that is AB. So it's a simultaneous eigenkets of both J square and Jz, and we saw that J square, the operator J square acting on the simultaneous eigenket, gives you the eigenvalue. We mentioned it as small a times the simultaneous eigenket AB. Again, we told that Jz, when acting on ket AB, will give you the eigenvalue B times ket AB. In the same video, we discussed on the ladder operator J plus, and we defined J plus as equal to Jx plus Ijy. Okay. So we'll just give it an equation number 4, and J minus as equal to Jx minus Ijy. Let's put it as equation 5. And in the same video we discussed how the commutation relation between J plus and J minus would be, and we found that it was equal to 2h cross Jz. In this video, we would find out the commutation relations on Jz. So Jz on J plus commutation we have to find out. So that will be a fourth one. Okay, fourth commutation relation. Now we'll just substitute for J plus and see how it will look like. So Jz, tell me it is Jz, comma, J plus means it is Jx plus Ijy. Now this we can expand as A comma B plus C commutation is equal to A comma B plus A comma C. So let's do that here. So this is your A, this is B, and C is I, J, Y. So this equation will become JZ, comma B is JX plus JZ, comma IJY. So I is constant, so we'll take it outside. So here you can see that JZ, JX is even permutation. The basic commutation relation is, as I told earlier, what is it? JI, JJ is equal to I epsilon IJK, JK. So here we have Z and X, which is even permutation. So it will be positive. Epsilon IJK will be plus 1 IH cross here. Okay. It's become IH cross. This term will become IH cross JY. Again for this term, tell me, it is plus I J Z Y. So this odd permutation and epsilon I J K will become minus 1. So it will minus I H cross, what is it? Z Y. So it is JX. So this will become I square, and I into I is I square, that is minus 1, and here you have minus again, so it becomes plus. Okay, so we can write this as equal to IH cross JY plus H cross JX. So picking that H cross common term outside, give you, and rewriting it, JX plus IJY. So we know this JX plus IJY is nothing but your J plus. So it is equal to J plus. So we found out JZ, J plus S equal to the commutation JZ, J plus S equal to plus H cross J plus. So this is your, so first one was the basic commutation relation. Then based on that, we J square, we had another commutation relation. And thirdly, it was based on J plus, J minus, and this is the fourth commutation relation. Similarly, you can also prove that JZ, J minus commutation is equal to minus H cross J minus. So prove it for yourself. If any doubt, please put it in the comment box. Next, we have to look into how JZ commutes with J plus. Okay, J square commutes with J plus. So let's look into that. So it is J square. One sec. So J square and J plus. So let's first of all, you know what is J square is? It is JX plus JY plus JZ and J plus is JX plus IJY. So we'll just first substitute this J plus as J square comma JX plus IJY. So expand it. It is A comma B plus C is equal to A comma B commutation plus A comma C commutation. So just let's look into that. It will become J square JX plus I put it outside, J square JY Now substitute for j square, and you know j square is nothing but equal to jx plus jy jy plus jz. So let's see how it will look like. jx comma jx. Okay, I'm just expanding it and writing it. I'll rather this substitute. So jx jy plus jz comma jx. Okay, then this terms plus I jx plus jy plus jz comma jy. So we have a plus b plus c comma d. So it will become this equal to jx comma jx plus jy comma jx plus jz comma jx. Then these terms plus I jx comma jy yes plus I jy comma jy plus I jz comma jy. This will look like y. Now you can see that this will go to 0 and also this will go to 0 because repeating integers. Now we'll just expand this. Okay, we have quite a number of terms. jy. So ab comma c. What is ab comma c? Reminding again and again. A commutation bc plus commutation ac times b. So it will become jy times jyx plus jyx commutation jy. Okay, that term is solved. Now this term plus, just tell me that it is jz jx plus jx times jz. Again these terms, the I terms, I of jx jy plus I jx jy times jx. This term plus, tell me this, I jz jy plus I jz jy times gz. Now using our basic commutation relation, you can see that here you have jy jx, so it is odd permutation, it is minus I h cross jz, so it will become minus I H cross. You have Jy here, this one, Jy, Jz. Here again also you have odd permutation, you have minus I H cross, Jz, Jy. Again here, looking here, you have here Jz term. This is an even permutation, Zx, so it will be plus IH cross Jz. Just put it another color so that plus IH cross, tell me it is Jz, Jy. Again for this it will become Zx, it will again even permutation plus IH cross, it is Jy, Jz. Again here I terms plus I Jz, look here, Z, Y, so it is odd permutation, no? So it will become minus, oh god, this I forgot, this one, this term, I have to write down this term, it is, tell me, it is I Jx, okay, Xy, so it is even permutation, so it is plus IH cross Jz, and again here you have, tell me, plus I Jx, Jy, again it is even permutation, Jz, you have Jx. One I is there again here. Then about this term, tell me, here this term, we'll write it again, I Jz, Zy is odd permutation, so you have minus IH cross Jx plus I here, again odd permutation, minus IH cross Jx, Jz. So this is what we have. So we'll just look into, you have minus IH cross Jy, Jz, just look here. Again you have plus IH cross Jy, Jz, minus IH cross Jz, Jy, here you have plus IH cross Jz, Jy. Again just when you look here, it is I square, so it is minus 1 minus Jx, Jz, H cross, okay, this one, and again you have here, just look, here just look, it is again I square, you have minus here, that means it becomes plus, and H cross Jx, Jz, so this term again gets cancelled, and similarly when you look, you can see this also gets cancelled. So the base, so what we have, the commutation, J square, J plus, right, commutes with J plus, or we can write in short, J square comma J plus is equal to 0. Okay, this is your fifth commutation relation. And you can also verify that J square commutes with J minus. So do it for yourself. Enjoy quantum mechanics. Thank you all.